So now I am going to discuss an example to find out the moment of inertia where a circular disk, moment of inertia of a circular disk through its center perpendicular to its plane. So let me consider a circular disk and say the circular disk is placed in xy plane and this is z axis. This is the disk placed in xy plane and z is perpendicular to disk, right? That's what we are considering here. Now consider a circle inside it and say consider a ring whose width is dx, its width is dx, and say it is x and say this distance is r. So let m be the mass of disk having radius r. So if I consider a elementary ring whose radius is x and width is dx, then now consider mass per unit area. It is the total mass divided by total area of the disk, and mass of ring is equal to mass per unit area into area of the disk. It is the area of the disk. So that means this pi will cancel out with this pi. So it is 2m over r square x dx. Now moment of inertia of this element through the center perpendicular to its plane, that is z axis, it is represented as, this is equal to mass of element multiplied by its perpendicular distance, and perpendicular distance will be x and its width will be this one. So it is 2m over r square x dx plus x into x square. So therefore total moment of inertia is basically, it is the integral of this one, is the total moment of inertia of the whole of the disk, and it is 2 pi over r square, and it is x into x square, it is x cube dx. So it is 2 pi over r square x 4 over 4, and for disk it varies from 0 to r. So it is integrating from 0 to r. So let us have a look at the diagram, because disk is varying from 0 to r, right? This is the radius of the disk and it is varies from 0 to r. So that's why I am integrating it from 0 to r. So it is equal to 2 pi r square r4 over 4. If I simplify this integral, so it is, this will cancel out with it, so it is, and this 2 will cancel out with it. So and pi is not there, okay, pi is missing because pi is cancel out, right? So let me correct it. First of all, pi should not be there, right? Yeah, it's 2m not pi, right? Let me correct it. So it is 2m 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 and 2m. So it is 2m, sorry, not 2m but this 2 will cancel out, so it is 2mr square. So this is a way that this is the moment of inertia of a circular disk about the axis passing through the axis which is perpendicular to the plane of the disk. Right, so that's all for this lecture.